Alright guys, here's a video, the review. Trying to get this posted as soon as possible. I have the partial P notes on here, things that you need to know. I told you which ones are test like. I'll have them circled on here as we're progressing. So on this first one is the test like. We will be using a special right to get to the answer for the height. Since this is 50, then the short leg is half that, which is 25. And to get to the height, which is the long leg is always whatever the short leg is times radical 3. So the height here basically is our 25 radical 3. And then our base is 60, so we're just going to plug it in. To get the area, you do 60 times 25 radical 3. And that's why we have 1500. Oh, excuse me. Square root of 3. Here, you're going to see the same type of triangle. I'm just going to change the numbers. You need to understand the triangle is the bold lines here. Okay? If this is an obtuse triangle or a scaling triangle, you can have whenever you have an obtuse triangle, the height can be and will be outside. So, in order to find this height, you're going to be expected to use Pythagorean theorem, or I can make this into a special right, but this one is Pythagorean theorem. So you would literally have to do 9 squared, because that's the leg, plus the height squared is equal to the 15 squared. 81, and then 225, subtract the 81, we get the height squared is 144, and then you take the square root, and so that is how my height was 12. So now that I have my height is 12, I can plug it into the formula for a triangle. Triangle is base times height divided by 2. The base is the 18, the height is the 12, so 18 times 12 divided by 2. We get 108 feet squared. Also, make sure we don't use the dotted line, the imaginary. Dotted means imaginary, okay? We're using the bold when dealing with the triangle. That was also a test light. And then 3 was a test light. So, on 3, let's see, move this around a little bit. On 3, what we need you to understand is you're going to use properties of parallelogram. Opposite sides are parallel. So that means consecutive sides are supplementary. So if this is 135, this has to be 45 so that their sum is 180. Also, opposite sides are parallel. Opposite angles are congruent. So if this is 45, over here is 45. Now this is not drawing the scale, but now we're going to use 45, 45, 90 to find the height. That means this is leg, this is leg, square root of 2. Well, if I see this is 6 square root of 2, then I know my leg, which is my height, is 6. So to find the area of the parallelogram, that's just base times height. So we're doing 15, which is our base, times our height, which is 6. This is how we got 90 units squared. Alright, and then this next one, number 4, it's a trapezoid. You do not have to find the height or use any special rights. We're just plugging into the formula. Make sure you know your part. So the area is 1/2 base 1. It doesn't matter which order you do. 15 plus 11 times the height, which is 6.2. Height's always perpendicular. I know the box is missing, but it's your distance between the base. And so we are going to do order of operations. We're taking 1/2 of our 26 times 6.2. So you can take the half of 26 or half of the 6.2, but when you work it all the way out, you should have 80.6 units squared. Half of 16 is 13. If you needed it, it's just 6.2. Alright, so on number 5, make sure things you need to know about diagonals, because in case I give you a rhombus or a kite, the diagonals get bisected, there's tick marks there. So if I'm showing you this one is 9, it's 9 over here as well. When I'm showing you that part is 6, it's 6 here. So you have to do the whole diagonal. So the long diagonal is 18, 9 and 9 is 18, and the short diagonal is 12. So when I plug it into my formula, we're just doing 18 times the 12 divided by 2. This was 108 meters squared. And then number 6, which is test like, understand if I have a square and I draw the diagonal, we create the special right 45, 45. I put on here, I have to go from the hypotenuse to the leg, you divide by radical 2. You rationalize it. This can be simplified right here. This 12 divided by 2. So the leg is really 6 root 2. So 6 root 2 and 6 root 2. Now to find the area of a square, we're just going to do base times height, or if you want to say length times width, or if you want to say the side squared. So basically, if I do 6 root 2 times 6 root 2, the parts that get multiplied together are 6's. 6 times 6 is 36. Times, then when I do root 2 times root 2, that's the square root of 4. What's the square root of 4 is 2. You should know, anytime multiply a radical to itself, get rid of the radical, you just keep the radicand, the number inside. And that's why this was 72 meters squared. And then we have number 7, which is also test like using the Pythagorean theorem to find the height. This is, hopefully we can see this just real quick. It's a triple 3, 4, 5, so the height is 4. Or you can actually work it out. I started it here, so you can actually work it out. You would have got to the h is 4 if you did it that way. And then now we have the height, so we're going to find the area. We're going to do base times height. So our base is 7, our height is 4. We get 28 units squared. And 8 is also test like. And I will be asking you to work backwards, using the formula work backwards to find the missing part. So we know that the area is 234. I'm replacing that for A. 234 is equal to, one of the diagonals is 26. We're trying to find the second diagonal. If we do 26 times the diagonal, 2 divided by 2, that equals 234. So the first thing I want to do, I need to get rid of the division. So we have to multiply by 2 on both sides. This now gives me 468. Is equal to 26D, D2 or D. And now I can solve for the diagonal by just dividing by 26. And that would give me 18 centimeters. And that is working backwards to find your diagonal. You will have a problem like that. Alright, so that takes care of the first page. If you need to go to certain parts, just use your fast forward button, and that will help you get to the problems you need explanations to. Alright, thanks.